Hey everyone, welcome back to another lesson. Today is part 2 of division with polynomials. Part 1 was long division, right? And we discussed it. Part 2, we're going to talk about synthetic division, and we're going to do 3 examples. Okay, the first example, we're going to make a comparison between long division and synthetic division. Then we're going to do 2 more examples where there's some, I don't want to say special cases, but cases that are not typically normal when it comes to synthetic division. And then that'll be it. We'll kind of conclude and wrap up division with polynomials. Okay? So let's just jump into it. Now, I have a problem up here already, and if I was going to divide this, this would be my result. Okay? And notice, when I'm going through this division process, I want you to take note that the first term I'm always trying to get rid of, right? Which is how we know what to write up here. Okay, in this quotient part. So I'm more focused on the second half of the value of these numbers here, right? I want to know what these guys are, because that tells me if I have a remainder or not, which indicates a lot for a problem. If there's a remainder, this doesn't go into that evenly, therefore not really a solution to this type of problem. If it does go in evenly, then the remainder is 0, and that can actually help me find the factors of this guy. And we discussed that a little bit before, and we discussed it in class a little bit too. Now, synthetic division takes that idea a little bit. It says, okay, if I'm only focused on here, then I don't have to really worry about the x's as much. I just have to worry about this value, because that's going to tell me what the other values are going to be. So to start synthetic division, we're going to go ahead and just make a nice little L. Pretty much you're taking this and flipping it. And just based on that observation, I'm only going to worry about this guy. Now, take note. When I multiply this by -2, when I'm multiplying these out together, you see how it's always the opposite of that sign? Because of the subtraction, right? We're always subtracting this. So it becomes the opposite of it. What I'm going to do is just take the opposite of this guy now. So I'm going to make it a 2. Okay? That's going to take care of me subtracting. I don't have to worry about subtracting anymore. What I'm going to write in this area are the coefficients that are in front of each part here. Okay? So the x cubed, there's a 1, then a -4 in front of the x squared, a 6, and then my constant at the very end is a -4. Okay? Now, because there's a 1 in front of here, okay, I'm not really changing nothing. I'm just going to go ahead and bring this down, okay? This is always going to be the pattern for it. You're always going to bring that first value down. And I'm going to go ahead and put plus signs in between the columns here. Now, here's the process, okay? I'm going to take these two numbers and multiply them together. So I get 2. The answer I'm going to write up here in this space, okay? Then I'm going to add them. -4 plus 2 gives me a -2 for that guy, okay? Now, notice something? -4 minus a -2 is like you're adding it. Boom. Answer's -2, right? See how this is what this is? Because once again, the first one I'm always canceling out, so I don't have to really focus on that. Repeat the process. 2 times -2 gives me a -4. 6 plus -4 gives me a 2. And then to finish it, 2 times 2 is 4. -4 plus 4 gives me a 0. The last column is the remainder, all the time. And in this case, my remainder is 0. Just like it was over here, right? It was 0 for us. Now, what do these values represent? They're the coefficients or constant of the answer. And notice, it's always 1 less than the highest power in your polynomial, right? And then you go in decreasing order. Because I start at x cubed, this guy's going to be a 1x squared. I'm not going to put 1 there. I'll just leave it as x squared. Then minus a 2x plus 2. And then that's it. There's no remainder, so I don't have to add anything to it. Notice, we got the same answer, huh? And continuing the noticing part, look at this. 6 minus 4, isn't that what this is? 6 minus 4. I know we're adding it, but it's the same thing, right? I get 2, which is down here, and then continue. So realistically, see how we're taking this concept, but we're just breaking it apart into its coefficients, and we're just focusing on that part. The plus signs are taken care of by this because we're taking the opposite of that guy. If this is a positive 2, you make that a negative 2. Okay? So we're already taking care of that pattern. There's a lot of comparisons here, and we can see what they did to make the synthetic division work. Okay? Which is really cool. It is. Think of it back with matrices. Remember when we were solving a system? Something like this? And we said, you know what? We don't really need to know what x and y are and their positions. We just need the coefficients. And that's what we did, okay? We set up an augmented matrix to solve that system. Kind of the same principle here. We're just taking a look at just the coefficients and numbers, and we're solving with them, okay? So kind of a cool comparison between the two. Now for this to work, you have to be careful. You have to sort of, I hate to use the word memorize, but you have to memorize the process for this. It's always the opposite of the value here, okay? Then you have the coefficients on top. You're adding, going across. Then you're going to multiply these two values, put the answer here, add. Multiply, here, add, and keep going, okay? If there was a remainder, you would do the same thing. You would add that remainder to your answer to finalize it. And that's synthetic division. I do have step-by-step instructions in my notes. Feel free to take a look at that. Okay, but this is at least showing you one example of how it's done. Okay. All right. 2 more to go. So, example 2. All right, I have this guy right here. Now, I'm going to go ahead and solve this. Now, notice there's a value in front of here. Okay, that's going to make things a little interesting because remember, when I made the statement over here, because this is 1, I don't have to worry about that value as I'm going through. Well, I got a 2 in front of here now, so I have to worry. Let me factor that out, okay? So let me just rewrite this. 4y cubed minus 6y squared plus 4y minus 1 all over 2y minus 1. And what I'm going to do, remember, this is the same thing as this, right? I didn't change it. Is I'm going to factor a 2 out of the top and bottom. Now, I have to do that to both, okay? So if I factor 2 out of the top, I get 2y cubed minus 3y squared plus 2y minus a half. When I factor a 2 out of the bottom, I get 2 times y minus a half for that guy. Okay? The 2's are going to cancel. Therefore, this is going to be my new division problem. Now, I didn't change anything. It might seem like I did, right? You're like, wait a minute. Does that change the answer? It doesn't. Look at a very basic example. If I started with this, 12 over 4, and I wanted to reduce it, if I factor a 2 out of both of these, okay, just like I did up here, see how I'm doing the same pattern? Get rid of it, I get 6 over 2. Now, is 6 over 2 the same thing as 12 over 4? Absolutely, they're both 3's. Am I changing the value of it if I reduce a factor out of this? No, I don't, okay? Same thing here. I'm factoring a 2 out, so I'm not really changing anything, okay? All right, now, following the same path as this guy, okay, is I'm going to take the opposite of the value. If it's negative a half, I'll make it a positive half. All right, just like that. Then I'm going to take the coefficients in front of each one and the constant and write them in here. I got a 2, negative 3, a 2, and negative a half. Okay? I know there's fractions there. It's fine. Don't run away. Don't pause the video. Don't stop. Fractions are okay. Half's not too bad to work with, right? First value, we just carry it down. Okay, nothing really changes. We always mimic the first value, just like over here in long division land, right? We're always kind of mimicking that first value here, whatever it may be. Now we put the plus signs here so that we don't forget it, and we go through the same pattern. Multiply these two guys together, I get a 1. Negative 3 plus 1 is a negative 2. Multiply these guys, I get a negative 1. Once we're done adding, I get a positive 1. Multiply these two, I get a half. And if I add them up, I get a 0 for that guy. So far, so good. Now, remember, the final result is going to be 1 less than this guy, power-wise. Therefore, this guy has to be a 2y squared minus 2y minus 1. My last column is always representing my remainder, and since my remainder is 0, I don't have to worry about adding anything to this result. Okay? Therefore, I can say that 2y minus 1 is a factor in this guy. Okay? If I multiply 2y minus 1 times this, I get this guy right up here. Okay? And I encourage you, pause the video, check it. Multiply these two guys together and see if you don't get this guy. Okay? You should. You really should. All right. Now, we got one more example to go. Okay, let me change some things up. Oh, bother. I want to keep that. There we go. Sorry about that. All right, we'll just put the example right here. I think that's a good idea, right? We'll put the example right next to it. All right, last one. Okay, so we're going to try this problem out. There we go, try to fit it into the screen. And notice, I do have a 2 in front. If I'm going to use synthetic division, I have to make that a 1. If it was normal division, you didn't have to. With long division, we could work with this. But with synthetic, because we're working with just the coefficients and going under the assumption that the first term is usually just copying that first coefficient, I can't do that no more. So let's go ahead. If you want to, why not? You know what? We're going to. We're going to rewrite this. Okay? And what we're going to do is we're going to divide each one by 2. Okay? So I'm just going to skip a step. I'm not going to go too far. We're going to jump right into it. Take a 2 out. I get 4x to the 4th minus 2x squared plus a half x plus 2. And then down here I get an x plus a half for that guy. Okay? This is what I'm going to divide. Let's go ahead and do that. We take the opposite of this value, so we have negative a half. And then we're going to use the coefficients and constant here, so we get 4, negative 2, a half, and a plus 2. I encourage you, okay, pause the video and try it out yourself before I give you the answer. First term we always bring down. We'll put the plus signs here. So negative a half times 4 is, what, negative 2? Add these up, I get a negative 4. Negative a half times 4 is 2. Add these guys up together, I get 2.5, right? Or I could write this a little differently. Let me write this as what, 5 halves, we'll put it? Something like that. And did I do this right? Oh my goodness. I missed a very crucial step. Pause the video. Stop the presses. No wonder. You're probably thinking, oh no, he's erasing everything. And I apologize for that. My mind was in autopilot. There's one thing I got to talk about. You see it? See how this is different than the other problem? I have 4th, I have a 2nd, I have the 1st, but I'm missing a 3rd, right? If I go down the row here, okay? And I apologize for this. I really do. Like I said, it's just, my mind just kept going with it. There's a reason why this problem's separate. I am missing an x cubed value, okay? Now, because I'm missing that value, I'm going to put a 0 as a placeholder for it, okay? Because as I'm going down through the ranks, I'm still going down through the powers, okay? So since we have no x cubed value, we will put a 0 as a placeholder. Okay? That's what we're going to do. Well, let me go ahead. I'm going to rewrite this now. So I have a 4 for the x4th position, a 0 in the x cubed position, a -2, a half, and then a 2 for that guy. Okay? Let me just, my writing's kind of blocking that, okay? So I do apologize for that. I wish I could just delete that chunk of the video, but I don't think I can, okay? There's a 0 as a placeholder. Now that works for long division too, by the way. When you're using long division and you're missing something as you're going down the powers, I mean, I could have more than one thing missing here. If, let's say this was to the 5th power, and I'm missing the 4th and 3rd term, then I put 0s in for those guys, okay? Same process. I'm not really changing much when it comes to that. All right, now we bring the first term down, and we're going to add the rest. When I was looking at my answer key off to the side, I was like, oh no, I forgot the 0 part. All right, -1/2 times 4 is -2. 0 plus -2 is -2. Multiply these guys together, I get a 1. Then I get a -1 after that. Multiply these guys together, I get a half. Adding those up, I get a 1. So far, this is looking a lot better. A -1/2 times 1 is -1/2. Add these two together, I get, what, 1.5, or I could say 3/2 if I want to keep it as a fraction. Keeping with the same pattern, if we start with the 4th, now we're going to start with the 3rd. So I have 4x to the 3rd minus 2x squared minus an x plus 1. Uh-oh. I have a remainder now, right? So it would be plus 3 over 2 times what? X plus a half for that guy. I'll put it over my, what I'm dividing by, right here. Okay. So this would be my final answer. Okay. Once again, if there is a value missing as you're going in descending order, you have to put 0 as a place value. Okay? Unlike what I was trying to do at first. It's just your mind keeps going in a rhythm and you just keep going. You're like, yeah, this works. This works. No, it doesn't. Okay? So that's it, guys. That is synthetic division. Okay, a good comparison between long division. For my assignments and stuff, you get to choose which one you'd like to try out. Okay? There is a benefit to synthetic division. There are less steps involved, but you kind of have to memorize those steps a little bit, right? You have to remember what you need to use synthetic division. With long division, you can just jump right into it. Okay? You don't have to really worry about changing signs and making sure these are plus signs and so forth. But once again, just a preference, okay? I kind of like long division a little bit better, but you can use anything you like, okay? That's the beauty about mathematics. There's so many ways to solving a problem. Whatever you like doing the most, use it, right? Okay, guys. Hey, that's it. Hope you're having a great day, and I'll see you all in the next lesson video. Take care.